For our friends at home, we've got the force, the applied force, and time. I said that this is force of friction, but you would have to really kind of think that through, and that's also non-trivial. Here's my block, and I'm pulling it, and here's the weight on top, right? And I'm applying a force. Oh, you can't see it still? I'm sorry. There you go. Now you can see my picture. Here's my applied force. Here's the frictional force. And I know that the applied force and the frictional force have to be equal. Why? Because it's not accelerating, right? So I would write an F net equation down. Hold on just a second, okay? So I'm going to write an F net equation down that says that FF equals FA, or excuse me, FF plus FA equals MA. A is 0. So FF has to equal FA. So that means that this line here, so this is me pulling harder and harder and harder. If I stopped right here, have I overcome static friction yet?
No.
I have not. So I'm still somewhere less than this mu s times Fn. Okay? I overcome it. Something else is happening here. What's my net force here? Or what's it not? It's not 0, right? It's not 0 in this funny little part that isn't highlighted. But down here in this green part then, in this green part, my net force is 0 again because it's not what? Yeah, F net is equal to 0. But now I've got FF kinetic is equal to mu K Fn. Not trivial. Maybe I just didn't make a big enough deal about it when we were doing the lab. Okay? But this part and this part are important. So you were looking just at that little dot at the top right here, because that's that maximum spot. And then you were looking at that average piece. And then you graphed. I mean, that was just what you got from Vernier. But then you graphed it. And what did you graph on the axes? What was your independent variable in this lab? What was it? What was the question you were trying to answer? You didn't remember? No, because I thought it was a dope lab. But I'm telling you it's not a dope lab. Now, what was it? What were you trying to find? You're trying to find a relationship between blank and blank. Was it mass?
Yeah.
It was. It was mass, right? The mass that you were putting on here and the applied force or the frictional force. And does it make sense that if you look at this pink dot or if you look at this green part, we can say that FA is equal to FF?
Yes.
Because really what we're measuring here is FA? Yeah?
Yeah.
Non-trivial, friends. Do you guys know what it means to say non-trivial?
Factual. It's important.
It's important. Have you ever played Trivial Pursuit before? Yeah, my husband's really good at Trivial Pursuit. You know what that means? He knows a lot of random stuff. That's not super helpful. He knows some stuff that is helpful too, which is good. But all that trivial knowledge, trivial means it doesn't matter, right? How many of Edgar Allan Poe's great nephews played in the 19-something Notre Dame football team?
2.
Why? I don't know. Like, why do we need to know that? We don't. It's trivial knowledge. It doesn't matter. I was really mad because I was supposed to win on that one. I didn't know that piece of information. Anyway, not that I'm bitter. Anyway, this is not trivial. This does matter, right? I know it's like this is Carbling coming out. I'm a little bit competitive when it comes to board games, so watch out. Anyway, all right. So FF and M. Thinking about what we know here. What should this graph look like? Let's think it through. Let's think about this one here. We've got FF and we got FA. What else have you got applied? Got a gravitational force? Got a normal force? You with me there? Let's think it out. F net. In the y direction, you've got FF, or excuse me, you got FG and FN, and they have to add up to what? 0. So that means that Fn equals mg. Are we okay there? Am I making wild and crazy claims, or are we okay? We're okay? F net in the y direction, oh, by the way, we said was FF equals FA. We know, we'll talk about the kinetic piece here. FF equals mu Fn. But Fn is really mg, right? Mu k times mg. We okay with what I'm doing here? Nobody's upset yet? Nobody's yelling or anything. That's good. Did the coefficient of kinetic friction change during this lab at all?
No.
The coefficient didn't change. That's just the two materials next to each other. Same materials, the same coefficient. Did the acceleration due to gravity change? Hope not. We did it all in this same lab, and it wasn't like there was weird stuff going on that I'm aware of. So really, we've got this and we've got this. The force of friction equals some constant times m. What should that graph look like, guys? Force of friction equals some constant times m. Should be a line, shouldn't it? Y equals mx plus b. There's no b. You guys with me there? This is the epitome of AP Physics 1. We got to linearize it. We got to understand where it's coming from. So you should be able to, from your graph, and I'm not saying you had to, but I'm just like letting you know, not a trivial experiment. You should be able to, from this graph, tell me what the coefficient of kinetic friction is. You with me there? Yeah, because you know that you've got a line, and the slope of that line, oops, I'm going to draw on the side, should be equal to mu k times g. Oh, and you know what g is. 9.8, right? No problem. So you're set. Hey, I have a question. Now that you know that, if you put the other one on there too, the static friction one, what should that one look like? Silence. What should it look like?
Linear.
It should be a line. Now, follow-up question, Henry. What is the slope of the line?
You gotta go up there and draw it.
1 over m.
No. That was the wrong problem. What is the slope of the line? Help him out. Lucky guess, because he knew it's all about lines. What should the slope of the line be? Go.
Is it US times G?
Indeed it is. And now my next follow-up question, because that's what I do, right? So the slope is mu sub s, so the static coefficient of friction times acceleration due to gravity. Is that graph going to be steeper or less steep than this one?
Steeper.
Steeper. Why steeper? 50-50 shot, I got it right, but now I have a follow-up question. Oh, man. Why steeper? Why steeper?
Because it takes more, more applied force to overcome friction.
Boom.
Boom.
There you go. Nice work. You got that. Is this making sense?
A little bit.
A little bit?
Yep.
If you're working on it this weekend, like, I don't know, tonight or something, and you have any questions, you can get hold of me, right? Carveling, this doesn't make a lot of sense. Now, some people that I saw that had graphed this did not get something that was a straight line. Like, I don't know what to do. So that's when you need to look at things and, number one, make sure that you've done things right? Make sure that you've actually recorded things and calculated things, and make sure that Google Sheets isn't eating your data and spitting it back up. Because we know that it will, don't we? You have to play really nice and like, what the is
This
that?
is the best
I
one.
don't know. That means nothing. This means nothing at all to a physicist. This is nothing. Like, what is that? I don't even know. No. All right. Are we okay? I want to do a lab. I want to be done with this. Are you guys okay? Do you understand what you need to do? Okay. If you want a 0. I mean, it's easy to grade if you do that, I guess. I'm sure it was.